Hello guys, welcome back to my YouTube channel Tech Audio. My name is Bharat Kumar. So guys, in this video, I'm going to explain Advanced RAG lesson number 1 using Pinecone vector database, GROQ LLM and also Cohere Rerank model. So it is the lesson number 1 under the series of Advanced RAG. So guys, in the previous video, I explained intermediate RAG application using Milva's Lite DB. So if you don't have prior knowledge of naive RAG or else intermediate RAG application, you have to watch those videos. I'll leave a link in the description below. So go and check it out, the playlist. So guys, why I'm telling to watch that videos means because in that video I explain how the RAG starts and how we change it to the intermediate RAG. So now in this video, I'm moving forward with the advanced RAG concept. It is the lesson number 1. You got it right? So guys, if you haven't subscribed to my YouTube channel, please hit that like button and also subscribe to my YouTube channel. So now let's begin the advanced RAG lesson number 1 concept. So guys, now you can able to see the 3 RAG process flowcharts. First one is naive RAG, second one is intermediate RAG, and third one is advanced RAG lesson number 1. So this concept we are going to discuss in this video. So guys, coming to the first step, I'm loading the PDF. In this step and in the intermediate RAG, I use the same concept, loading the PDF. So guys, before beginning the lecture, it is only for the example way. So you can able to change splitting, embedding, vector storing, similarity search, re-ranking and LLM models. So guys, it is only example flow how advanced RAG works. But feel free to change all this where you need change. It is only for the educational purpose, not for the real life RAG production. So loading the PDF is completed. So coming to the split documents, here I used recursive text splitter, but in the first video I used the advanced technique which is semantic chunking. So now you can able to bring this concept to here to make it more advanced level. So coming to the embedding, here I used Hugging Face normal embedding model, but here I used advanced embedding model. Here I use, it is also advanced, but it is not advanced as compared to the PGE M3 model, but it is also a famous model. So coming to the vector database. In the previous RAG, I used Milva's Lite vector database, where we can able to download the database and we can able to see what is there in the data. But here I'm using the Pinecone vector database. So it is giving the serverless option. So we don't need to store anything in the local. So all the data is directly going to the cloud. They used AWS cloud. So coming to the chunking. So in the previous video, I used semantic chunking. But feel free to change this to the semantic chunking. In the next video, lesson number 2, I'm going to bring up hybrid search. So coming to the re-ranking, it is an advanced concept that I brought up in this lesson number 1. So whatever the documents that we are getting from the vector database, Pinecone, I'm just re-ranking it. Why? Because, for example, assume that we have 5 documents. Document 1, 2, 3, 4, 5. You got it, right? So, but our content which is there in the first and fourth, there is no order. But coming to the order of the content, so guys, for example, assume we have 5 sentences. So the first sentence should come at the first only, but the fourth is came at the first. It is not the correct order. So that's why this re-rank model is going to order the retrieved documents in a particular order based on the semantic meaning. You got it, right? So after re-ranking, I'm just passing those 5 re-ranked documents to the LLM model. So the model will take the context and also question, and then it is going to give the response. You got it, right? It is a flow. So compared to the intermediate RAG, I just added one more concept, re-ranking concept. But the remaining concept is same, guys. Splitting, embedding, storing. Try not to depend on only the single concept. Here I use recursive splitter. You don't need to use this concept. You can go to semantic. And also we got latest one, late chunking. You can go to that. So every day you need to evolve in the RAG. You got it, right? So guys, now let's begin the coding. So first of all, you have to install all these packages. LangChain, LangChain Community, LangChain GROQ, LangChain Experimental, PyPDF2, Pinecone Client, Cohere, and Tick Token. So these are the packages that you need to install. I'm not going to install this again because I have already installed it. So now let's import the package. Import PyPDF2. It is used to load the PDF. LangChain text splitter. Import recursive text splitter. So with the help of this, we are going to split the text recursively with this chunk size and with the overlap. I hope you already aware of overlap and chunks because I already explained in the naive RAG. And from LangChain community.embeddings, I'm importing Ollama embeddings. So for now, I'm using these 3 packages. So here, PDF equal to PyPDF.pdf reader. You just need to give the path of your PDF. So guys, I'm going to use the same PDF that I've been using in this past 3 videos. Now, PDF text equal to empty string. Page in PDF dot pages. So I'm just updating all the extracted text to the PDF text variable, and then text splitter equal to recursive text splitter, chunk size equal to 1000, overlap equal to 200. Now text equal to text splitter dot split text. So whatever the content we stored in this variable, I'm just passing it to the text splitter. It is going to split the text. So now you can see we got the one text, data science. So guys, you can see this is the split text. So guys, now before going to the embeddings, you have to download Olama. Olama download. So when you click on this one, it will open this website. Now just click on the download for Windows. So after downloading, you have to go to the downloadings. You can see here Olama setup. Just install this one. After installing, you can able to see in your local computer or local laptop. Now come to the VS Code, open the terminal. So first you have to install pip install Olama. So guys, I have already installed this Olama. After that, you have to pull the embedding model. Olama pull Nomic embed text. So guys, if you get this error, you need to close the VS Code and then open the VS Code again. If not, you have to restart the laptop. After that, when you execute this command, you can able to see it is pulling the model completely. You'll get the success after pulling it. So now here you can see I'm just defining a variable embeddings, Olama embeddings, model name equal to Nomic embed text. Here I have taken one more variable embeddings.embed doc. I'm passing this text is split by the recursive splitter based on this chunk size and based on this overlap. So it is going to give the embeddings. You can see all the text is converted to the embeddings. So guys, here you can see I import Pinecone, and from Pinecone import Pinecone, and Pinecone import Pinecone, and then serverless spec. So here in the PC equal to Pinecone API key, you have to give your API key. So come to the Google, search for the Pinecone, then go to the APIs, create one API key, then copy that API key, just put it here. Here it is only for the testing API key. I'm going to delete it after this video. So guys, here you don't need to give this API key directly. You need to import it from the .env file. So after creating API key, you need to create one index. Text v3 dimension equal to 768. It is the dimensions of this embedding model. So each embedding model has different dimensions. As you all know, in the previous video we used by 3 embeddings that has 1024 dimensions. But for this one we have 768 dimension. And matrix equal to cosine. So when we pass a question, it is going to perform the cosine similarity based on the stored data. Here serverless spec. So whatever the document that we embedded, so all this will be stored into the cloud AWS region equal to US East 1. So when you run this code up to here, then you can able to see this text v3 in the Pinecone website. You can see, and then matrix equal to cosine, dimension equal to 768, and it is a host. Cloud equal to AWS, region equal to US East 1, and type equal to serverless. So here we stored all our embeddings into the server directly in the AWS. So there is no need of storing in the local. You need to have the more configuration like GPUs, RAM. But here that concept is not required. See guys, in the previous video I explained Milvus Lite. We can use Milvus Lite. But when you go to the Milvus standalone and also one more service in the Milvus. And for that we need Docker, more GPU, more RAM, and also some cloud infrastructure. But here it is not required. They are directly offering via API. But to do that, it's completely different. But Milvus is completely different. You got it right? So here I like this feature of this Pinecone. So coming to their billing, so you can see they are offering 3 versions: starter, standard, enterprise. So here I'm using this starter one. For this, we can see the features: Pinecone serverless, Pinecone interference, Pinecone assistant, Pinecone console metrics, and community supports. So for the starter usage, they are giving this much free trials: 1 million, 2 million, and also 2 GB storage. Our storage is less than 100 MB. So because for this embeddings, I use the same PDF that I used in the last video. Data science PDF, it contains 37 pages only. So when I print the PC, it is giving the object. So now index equal to vc.index. I give this text v3 index name. Print equal to index. I'm printing this index. It is just a object. After that, for I in range, length of text, index dot upset. Upset means, so guys, you can see here I'm passing embedding and also corresponding text. You got it right. After that, get embeddings. Here I define one function, get embeddings. In that, here I just defined one variable, embedding equal to embeddings dot embed query. So it just embed query. In that embed query, we are just passing the text. So here, for example, I'm calling this function. In that, I'm just passing the text. It is going to embed this text. See guys, it is embedding of this text. So what we are doing means, after that, you have to import Cohere.client. Here also you have to pass your API key. So then come to the Google, search for the Cohere. After creating account, you have to create API key. Same. Create one API key and then command paste it here. So here I just give one question. Query equal to what is the data science? I'm getting the embeddings of the data science question, query result. So this result, I'm just passing this embedding to the index that I created previously. It is going to identify top 5 similarity documents, include metadata also. So let's see the query results. Query results. Okay, as you can see, these are the query results. So in the top K, we said 5. So it retrieved ID 48, it is the first document, ID 6 equal to second one, ID equal to third, ID 5 equal to fourth, and then ID 7 equal to fifth. It retrieved 5 documents from the vector database. So now, as you can see here, it is giving the score. That means it is performing the quotient similarity and then it is giving the score. Here for this text, we got 61. So as you can see, for our question, we got the 61 score for the first document. For the second one, 61. For the third one, it went back to 60. For the fourth one, 60. For the fifth one, 59. So we retrieved top 5 documents. After retrieving, similar text equal to a list. I'm just storing in the doc. So for the docs, I'm just storing all the similar text in the. So guys, you can see here we got the query results. So from that, I'm just taking the matches. Matches equal to ID. And then text and metadata. So here Rerank model. So from the Cohere, I'm just importing Rerank model. Query equal to query. Documents equal to list of document dot keys. Top n equal to 5. Return documents equal to true. So now let's see the Rerank documents. So these are the docs. You can see. After the query results, I'm just getting the docs and passing it to the Rerank docs. You can see this is the Rerank text. So guys, now let's compare our docs with the Rerank docs. Is it come here? You can see is come at the first, but here is at the fourth one. N equal to N came to the first. Potence came to the second. Mathematical came to the, as usual, mathematical came to the fifth one. See how it re-ranked. It took the documents, it just arranged it to the order wise. See how beautiful it is. So guys, you can see here it is the embedding model that I used in this video. These are the comparison between OpenAI models, Nomic embedding, and these are the OpenAI models. Is giving more options: open weights, open training code, and open data. You can see here Nomic embed text view one. It has the context length of 8192 text encoder. That surprises OpenAI text embedding data 002 and text embedding 3 smaller short and long context. So basically it is performing better than OpenAI embedding models. Because you can see, you can able to see the score here. 52.39, 85.53. Got it right? So that's why I have taken this embedding model. So coming to the re-rank model, the re-rank models sort the text inputs by semantic relevance to a specific query. They are often used to sort search results returned from an existing search solution. So what it means, it is our documents. It just using this and then sorting it to the order wise. So guys, when you pass this re-rank, the model can able to give the best content to us. So that is the one concept that I changed in this lesson number 1. So guys, don't get bored. You just need to understand the flow of rank. So here re-rank docs also completed. So after getting the re-ranked text, I'm just joining it to the context. And then I define my prompt template. Role equal to act as a data science expert based on the following context. Task equal to this is the content I have. Now generate the precise summary related to the question. I'm just passing the question. Do not remove necessary information related to the content. Instructions. Number 1. Consider /n as the new line character. Try to use the provided content for the answering question. Try to use the provided content for answering question. Here I just define the sample prompt template. But you need to experiment this prompt template based on your result. Okay. And then final prompt template equal to prompt template dot format. Here I'm just passing the text and then query. So this context, here I'm just passing the context and query. The context will be going to the model and then query will be going to this prompt. So the context will go to this context and then the query will go to this query. So now let's see the final prompt. So guys, you can see it is our final template, role, task. After the task, content. See, this is my content. Any short document is called up to here. All our content. And then you can see here, this is the instruction that I gave to the model. So it is a prompt template. The context is also going to the prompt. So now coming to the GROQ. From GROQ, import GROQ. Come to the Google, search for the GROQ cloud. Then go and create new API key. Come here, paste your API key. So coming to the pricing, they are giving 3 versions: free, developer, and business. For now, we are using the free only. So for the current plan, we just start with the $0. So guys, we can use the free limit of the GROQ, but with the low rate limits and community supports we have in the free version. So when you want high rate limits, then go to the developer. So what is the motive of using this GROQ cloud means? So previously I explained how to connect with the Ollama models in the Google Colab, but there we can't install bigger models up to the 11 billion parameters. Only we can install in the Google Colab for the free version, or else you need to buy the Google Colab, but it is not required because when you buy the Google Colab, we can't able to deploy it. So instead of that, then come to this GROQ. This GROQ is giving free access to the models with the low rate limits. So why to pay money here also? We just need to try and experiment it. Got it, right? So when you want to go to the production, then pick your own model, OpenAI or Cohere or Anthropic or Bedrock models, or else go for the developer pay in the GROQ. But it is coming soon. But for now, they have only 2 versions, free and business. So take your API key, then paste here. After that, I just define one variable, chat completion. Client.chat.completion create. I'm giving role equal to user, content equal to final template, model equal to Mixtral. Here I used Mixtral model, but you can able to use any model. But feel free to try your own model. Come to the models. So these many models are available. You got it, right? So in the next video, I'm going to use this big model, 90 billion vision model. Client is created, and also we have created this chart completion, and then I'm just executing this again. You can see it gave this content. So whatever the content it gave, I just put in the markdown. You can see it is the answer I got here. So if you want to change anything, then come to the prompt template, try to change your prompt template, then ask more questions. So guys, advanced RAG lesson number 1 is completed. So let's revise what we have done. So loading PDF is completed, creating the document is also completed, embedding the docs using Ollama model is also completed, storing the embeddings is also completed. Similarity search. In the similarity search, we gave top 5 and re-ranking. We also understood how re-ranking is working. And LLM model, we gave it to the Mixtral LLM model, it gave the response. That's it. Subscribe to my YouTube channel and also hit that like button. So guys, bye for now. See you in the next video.